Okay, so this is part 2 of my series on decision trees. In part 1, I described how they work, and in this video, I'm going to get into cleaning data. The next video, I'll get into kind of the meat of the code. But anyway, so for this project, I have 2 data sets that I'm going to share with you. The link will be in the description. Yeah, and before you can use them, cleaning your data is important in any machine learning task, and decision trees are no different. So these are 2 different data sets. The second definitely needs more cleaning, mostly due to the values being in characters. As you can see, there are some of these columns that do not have numeric values, and that's something that you need to have for running a decision tree. And so to help us out in the cleaning, we're going to use the Pandas library. And so you'll have to install it first. You can do pip install pandas, and then you import it in the top of your code. Then you're going to read in your data set. All right, so missing values is probably the biggest issue in data cleaning. With pandas, you have a few different options. You can simply use the drop NA, and that will drop any row that has missing values. However, that could be a little extreme, especially if you have data that has a lot of missing values in different columns, and not all of those columns are important to your application. Thus, you can use the subset tag, as you see right here, and specify which columns you'd like to examine for missing values, and only drop the rows related to missing values in those columns. So that's like, and you can have as many, and I'm showing you 2 columns here, but you can have as many or as few as you want. Instead of dropping rows, if they're missing values, you could use fill NA, which will fill a cell with either, and you can specify what you want it to be filled in there. There's many different options, but I'm just showing you a couple here. You can fill it with the mean, which is the average. So the average of all the values in that column will get filled in there, or the mode, which is the most commonly found value in that column. Sometimes that is actually a good idea instead of just disregarding the row completely. All right, yeah, so like I said, there's also the issue of dealing with non-numeric values. So for instance, this column on labeled sex, whether you're male or female, that is one that you would have to deal with because you can't leave that as M and A. To do that, we have the pandas function get dummies. This function will create a new column. For example, in that sex column, it will create a new column, sex underline male, and the values will be either 1 or 0 respectively, referring to male or female. And so there's no need for that old column, this column here. So you actually put in this drop first, which will delete that column from your data set. And so let's see what that actually looks like in practice. So you want to use this print statement that prints all the columns. So you'll see after running the get dummies that you will have a new column. So it's important to print this out so you see what the actual name of that new column is, because you're going to need to reference that in your code. If you look here, this is after this code ran. We printed the columns, we used the get dummies, then we printed the columns again. And you'll see, so there was the column labeled sex. After we used the get dummies, you'll notice that now it's sex underscore M. And so that's what we'll want to use when we're building our decision tree, if we decide to use that column. The only other thing that I want to kind of talk about is, you may have been wondering when I was showing you in the last video, there's certain categories or columns such as age or weight. It seems almost arbitrary how it's divided in greater than 30 or less than 18. Thankfully, we don't have to decide that. The Python library, Skykit, actually does this for us. There are calculations that it performs in the background. The code examines the data and finds the best spot to divide a category based on the outcomes. For example, I believe when we actually go to run this in the next video, the age data will be cut at 60-ish, right around there. And this is because, like I said, there's a formula that runs within the code, and it determines that 60 is the critical point, critical age, where most people above that threshold are more likely to have heart disease, and below it are not. And so, and that can change based on the branch that you're looking at. Like if you are here at a smoker and going down to look at age, it might be different on that subset of data. Anyway, I just wanted to point that out, and that's it. So next video, we're going to dive into the meat of the code. Hopefully you found this useful, and let me know if you have any questions.